Okay, kiddos from AP Stats, we are going over, well, maybe, this quiz question that is kind of a review of chapter 12.2. So I want to go over the answers with you, and then I also have for you, and you will be getting it today, the practice test that I want you to take home over the weekend and practice it. Let me see if that make that a little clearer. Okay, so here we go. Lupe is shopping for a used car and collects data on age in years and price in 1,000s of dollars for the Ford Taurus sedans on a used car website. On this page is computer output for 3 different regression models: price versus age, log price versus age, and then log price, let me see if we can make it a little bigger, versus log age. And we're going to see which one would best be linear. Okay, questions about these data are on the next page. All logarithms are base 10. All right, so now here's what we've got. We have our price versus age. The R squared is technically 0.89, but changing it to a percentage, 89.3%. But it looks more curved, right, than it does actually straight. Because even if you did a best fit line, you're not having points above and below the line the whole way down. If you did it in the center, you would have above, a section above, a section below, and a section above, because it would cut like that. Okay. Now, so, and the standard deviation would be, of the slope, would be 1.68336 off, on average. So, but here would be your constant, there would be your slope, and then we're going to look at this residual plot, and we're seeing that it's not spread out evenly. Because of that, like if you did the best fit line in middle, the ones up here would be above, the residuals would be above, and the ones down here, those residuals would be above. And in the center, they would be below. And note, for a linear shape, when you do the residuals, if it's going to fit good, it's going to be spread out. So we know it's above and below the best fit line. Okay, now this next one is log price versus age. And maybe zoom in just a little bit more. See if that helps. Okay. Now, here would be the constant. There would be the slope. Now, notice on here, the standard deviation off would be 0.047 blah, 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 but pretty low. And the R squared would be 97.9%, which is pretty high. And then let's look at it. It looks like a nice linear decline here, which is still linear. So make a nice linear regression. Now, so if you did a best fit line, you would have points above, well, let me do it this way, above the line and below the line, because it would fit nice and evenly in the middle. So if you see here, when they did the residuals, measurement of the residuals, some were above and some were below, and it's scattered everywhere, which means that that makes a nice linear regression. Okay, now let's look at this next one, and it is log price versus log age. Now, once again, everything is going downward. However, it's not quite as nice as log price versus age alone. So, and it's at a 92.3% on the R squared, with the standard deviation higher than the number 2 one. Okay, and you would have your constant and your slope. But now, if we look down here at the residuals, it's better than the very first one, obviously, but you're still having some down, some up, some down. So you can see, if you did a best fit line, you would have this first part would be underneath the best fit line, the second part would be above the best fit line, and the third part would be below again. So down, up, down. So that's not really a good situation either. So we basically answered the questions, but here's the formal way to do so. Okay. Now, explain how the information provided suggests that a linear model may not be appropriate for describing the relationship between the car age, and the price. So we're looking back at this one again. So why is this not, we kind of already talked about it, but we'll go through it formally. Why is this not a good linear regression? Now, here, oh, there we go. The scatter plot shows a curved relationship between the price and the age. And you can see that right here. See how it's kind of U-shaped or curved? Okay. This is reinforced by the distinctive U-shaped pattern in the residual plot, positive, negative residuals for high, positive residuals for high and low ages, and negative residuals in between. And you can see that right here. See that nice U shape right there? So positive residuals for this high stuff, negative residuals for the in-between, and positive residuals again for the low, because your linear regression would run somewhere in between, and these would have positive residuals. Hopefully that makes sense. Okay, now let's look at number 2. I'm going to get you all feeling loopy from this paper moving. Would an exponential model or power model provide a better description of this relationship? Use the information provided to justify your answer. Okay, so if we look at the next one, remember logs have to do with exponents. So they're describing the exponent, right? The plot of the log price versus the age, so the exponent with the base 10 of the price versus the age, is clearly linear. And the residual plot shows a random scatter of points on either side of the line where the residual equals 0. So let's look at that again. Okay, so what we said is if you had a linear regression, the best fit line in here, you would have points above the best fit line and below the best fit line all the way down. And this shows the residuals. It shows you would. All the way over, you've got points above and below. So that says, yes, the log price versus the age, okay, is going to give you the best linear regression model. So 97.9 or 97.7% with a fairly low standard deviation. Okay, so let's talk about the next one. It says the log price versus the log age. So we're talking about base 10, the exponents to base 10 of the price to get the price, exponents of base 10 to get the age. Okay, so scatter plot. Now, and the residual plot do not suggest a linear relationship, at least certainly not as good as the log price versus age. If log price versus age is roughly linear, then price versus age can be modeled well by an exponential function. And we know that logs are representative of exponential exponents, so that's why it's going to be nicely represented by an exponential function. Okay, now, so here's where we find, so it says give the equation of the model you chose in question 2 using the transformation variable. So we chose the second one, and so we're going to make a linear model out of that with the information on the printout. Whoa. So there is your slope, negative 0.090652, and there's your constant. That's where it's crossing the y-axis, right? 1.43723. So we plug that in right here to our equation. There's your y, the log of the price, equals, and remember they put this in the form of a minus b x. So here is your, where it's constant, where it's crossing the y-axis, there's your slope, and age is what we're talking about. That's on the x-axis. Log price would be on the y-axis, right? So this is log price versus age, so that's the one we chose. Now, finally, question 4, use the model you chose in question 2 to predict the price for a 5-year-old Ford Taurus. Show your work, okay? So here's our equation again, but instead of age, we put the 5 years old. Now that's giving us this number. that does not mean it costs 98.4 cents, right? That would be ridiculous. That is the exponent, because that's what we're talking about. Log base 10 of the price, that is the exponent to base 10. So, I wish I had a pen right here, but, so you put 10, well, we did it right here. So here's what you would use that as the exponent. And this is plain log, so that's base 10. So the predicted price is base 10 to that power. And then we get that 9.64, but this is in 1,000s or thousands. So then we multiply that by 1,000, and we get $9,640. That's the approximate price of a 5-year-old Ford Taurus. Okay, I hope everything's going well. If you have any questions, please feel free to give me a call this weekend. And please practice your practice exam and then bring those on Monday. I want to see your work. And then I've got some other flashcards that I'm going to copy for you and you can use to study for your exam. Have a good day, cherubs.